S. Chand presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Welcome to S. Chand Academy. Okay, now next topic is a torque speed characteristics. So in this topic we will understand ki how one motor that can act like as a generator and that can also act like as an induction motor. Now if you want to study this topic in detail, refer this book from S. Chand Publishing. E-book link has been given in the description box. So now I am Narinder Kaur. Let's begin with this topic. So there is a torque speed characteristics. Now in the previous lecture we have understand about the synchronous generator. In which type 1 configuration is preferred, and we also understood in this case losses are very large, means there are large eddy current losses and efficiency is also small. So based upon this, instead of synchronous generator, induction motors are preferred. Now there are some characteristics. Upon this we will understand ki how one system that can be used as an induction motor and as an as generator. So that is given by the torque speed characteristics. Now on this, if there is a speed and there is a torque, okay. So here this is an torque and along this there is an speed. Now you can clearly see here slip. We will define some of the parameter over here. One is a slip and second one is the slip speed. How that can be calculated? Now the slip speed and slip, how we can calculate all these parameters. So before defining that, firstly consider NR, this is a rotor speed, and NS, that is already defined, that is a synchronous speed. NR is a rotor speed because in case of motor there are two parameters, one is a static, second one is rotor. Rotor, that is in the rotating mode. So if NR is the speed of the rotor speed, and NS the synchronous speed, then slip is defined by this formula, that is equals to NS minus NR divided by NS. This is defined as a slip, and the slip speed that can be given by NR minus NS. Now instead of speed of this rotor speed or the slip speed, both of the characteristics that can be understood over the one graph. So if this can be the speed of the rotor or that can be the speed of synchronous speed, because both are related with the slip. So here we can write as the speed which is a synchronous speed or slip speed. So over one graph both the characteristics that can be understood. Now again there is a torque. So in the starting graph is like this. If this is the graph over here, now in the first case here this is called the induction motor case. Where NR is less than NS in this case. Second one, NR is less than N case, then slip S, that is equals to, what is the value of slip over here? Here the slip is equals to NS minus NR divided by NS, then it will be positive here. Its value is positive. Here, now in this, at this point, slip is 0. At this point here, in this region, slip is negative, because in this region, NR is more than NS. NR is more than NS. So this is the case of generator, synchronous generator, and slip is negative in this case. So slip is negative in this case. Now firstly, and the starting point. Here if this is the starting point, now slip is 1. How slip is 1? So this implies NR at the starting NR is 0. That means the speed of rotor is 0. If the speed of rotor is 0, here this point means some of the trigger is required over here. Some initiating value must be given to over here. In some cases when this is not required, they are known as self-induced motor or the self-starting motor. We can say that they are self-induced or self-starting motor. In that cases, NR is 0 and some of the trigger is required. Now after that, you can clearly see that as soon as the S goes on increasing, you can see that the value of the torque goes on increasing and it reaches a maximum value over here. So in this case, you can clearly see that over here, as a NR, that is a rotor speed, it goes on increasing, the value of the torque goes on increasing. So that is the first region. And also the slip, what is the value of slip over here? That is NS minus NR divided by NS. As soon as NR goes on increasing, the slip value that will be goes on decreasing. Means in the initial point over here, the S is maximum, that is equals to 1, and here the S is 0. Means up to this point, as soon as the value of NR goes on increasing, the value of S will goes on decreasing. So this is the first region. This region is called the induction motor region. This is the induction motor region, and in this case S is positive. Means a given system or the given geometry that will be act like as an induction motor. Now after this point, if this is A, so A here, A is called the trigger point. So in that cases, in some of the cases that trigger point is 0, or in some cases the trigger point is non-zero. When the trigger point is 0 means the system starts, or self-powered devices, these are called the self-powered devices, means no input is required in order to initiate the devices. But when some trigger or some initiative are required, so in that cases A trigger point, that is at some height they are non-zero. Now this is the value of torque over here. Now in the working region over here, if this is the working region, in this region NR and NS both are equal to each other. So here NR is equals to NS. So when NR is equals to NS, so in this formula slip that will be equals to 0. So here the slip is 0. So this is basically, now in this region from B to C region, from B to C. Now as soon as the value of the torque or S, that is goes on increasing, or you can see that the motor speed is goes on increasing, rotor speed is increasing, the value of torque goes on decreasing over here. So this is the mode of required operation. So means in this region, here in this region, motor start working. So this is a basically required or the mode of operation region. So BC region is basically, so here this is B. Now again, if this is a C point, so in this case here NR is equals to NS, means slip is 0 in this region. So this is a mode of operation region. So in both of the cases, from B to C point. This is the mode of operation region. Now again on further increasing NR. So here NR equals to NS. Now in this region NR is more than NS. Means the rotor speed is more than synchronous speed. Now what is the value of synchronous speed over here? Here the synchronous speed is, that is 120 F upon P. Means the rotor speed is more than this synchronous speed. In how that value that can be attained? So this can be attained by basically, now in case of rotor there are many parts which includes a magnetic field device or magnetic poles. So to the magnetic poles higher value of field is supplied. Now if the higher value of field is supplied, the poles starts rotating with the more speed. So rotor will start moving with the more speed. So speed of the rotor that can be increased. So NR that will be more than NS. Now when NR is more than NS, what will be the value of slip in this case? So slip will be NS minus NR divided by NS. Now if NR is more than NS, that will be negative. So this is not the required region over in this case. So in this case the induction motor will act like an generator. So that is not required. So this is not required. Okay. Means in the generator mode, slip is negative, NR is more than NS, and that is costly. Why this is costly? Because in order to increase the speed of the rotor, more value, or you can say that large amount of field is required, and that is not permissible. So in the torque speed characteristics, so this is a induction motor area, and that is a generator area. Okay. So now in the first part we have understood about the torque speed characteristics. Now in the second part we will understand how the resistance of the coil will affect these characteristics. Now if you want to study this topic in detail, refer this book from S. Chand Publishing. E-book link has been given in the description box, and if you like this video, please like, share and subscribe, and also press the bell icon for the future notifications.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.